universe appears as a dazzling array of lights, a sparkling canvas whose graceful motions mark the passing of time. For centuries, these images have inspired and challenged our imagination, daring us to uncover their secrets and determine our place in the cosmos.
All of the cultures that live on Earth live under the same sky. And all of the cultures that have ever lived on the Earth have lived under the same sky. The sky has not changed significantly in 10,000 years. And that means that every culture deals with the same problems, looking at the sky and trying to understand what it is.
If we really want to comprehend astronomy, we need to comprehend these changes that occur in the sky through the seasons and through the night.
This kind of astronomy that we're talking about is very simple astronomy when it comes down to it. It only takes two things, a place to stand and a place to look.
It is here, under a starlit sky, where the journey of astronomy began many thousands of years ago. To our most ancient ancestors, the sky provided order and guidance, offering important clues essential for survival.
Astronomy was originally rooted in practical everyday reality. The sky provided the basic means of understanding such things as direction in the landscape. That's where we get things like north, south, east, and west. It also provided the basic rhythms celestially for the passage of time, the regular cycle of day and night, the monthly packaging of the phases of the moon, the annual circuit of the seasons and the stars and the sun. All of these things were tools that people used from deepest antiquity, probably back to the old Stone Age, in order to help them organize their lives and adapt with wit to the environment in which they found themselves.
People who live in traditional cultures associate the changes they see in the sky with the changes they see in the earth. They know that when certain stars appear in the evening sky, in the early evening, or appear for the very first time in the early morning, that certain trees will bud, that certain animals will have their offspring. So these are all clues that are used for very basic human things, for when to plant, when to harvest, when to hunt, and so on.
Understandably, the people of ancient times watched the sky with fascination. There they saw reflections of themselves and their world.
Wherever we go to look for the signs of ancient astronomy, we'll find astronomical symbolism, the recognition that the sun has power and that the moon measures time and that the stars spell out the course of the seasons. But the forms in which these things evolve varies tremendously. They show up in the symbols, in the ceremonies, in the architecture, and in the myth of all of these peoples, but exactly how they show up depends on the character of the society and the environment they occupy.
We grow up with basically the Greek constellations today. We have, for example, the constellation of Ursa Major, the Great Bear, that contains the 7 bright stars we call the Big Dipper. But my Navajo friends don't call that group of stars the Big Dipper. They call the 7 bright stars, and some associated ones nearby, the revolving male. They refer to the North Star as the fire star, and they refer to the constellation we call Cassiopeia as the revolving female. And they associate this with being at home around the fire in their hogans and family values.
Chinese constellations are conceived very differently, often shown as little balls representing the stars and sticks connecting them. But the identities of these ball and stick constellations vary tremendously. For example, the Big Dipper is really a celestial chariot or vehicle in which a celestial bureaucrat or the emperor travels as he goes around the North Pole of the sky. Well, we can go around the world and find different interpretations of these different groups of stars.
We have the constellation of Scorpius in the south, a very beautiful summer constellation. It looks like a scorpion. The Pawnees separated it into 2 constellations. The first part, the front part, is a string of stars that they called the snake, and then the stinger of the scorpion they called the swimming ducks, and that set their whole calendar, those 2 stars.
While different cultures projected different images on the sky, one celestial object was regarded by all as the supreme power in the heavens.
You couldn't doubt that the sun had power, for when it came up above the horizon, it glowed. It glowed with intense light and changed the landscape from the darkness of night, which was often seen as a threat to people. In fact, even the underworld might be thought to be loosed at night. And so the sun came back and brought light and life to the world. And of course, you could feel the heat of the sun on your own face. And that was further evidence that there's real power, as there is in the sun.
Many ancient cultures tried to understand the sky, the ancient Babylonians, for example. Most of those cultures approached that understanding in a spiritual way. They saw the sun as a creature, a spirit, a god, moving across the sky day by day, eastward among the stars. Many of those cultures worshiped the sun.
Whether it was Re, the god of the sun for the ancient Egyptians, or Shamash for the Mesopotamians, it often represented very similar principles. The sun also was recognized as having a link to the life of creatures, plants and animals on the earth, because their seasonal changes seemed to coincide with the seasonal movements of the sun. So the sun was regarded as a source of order, and we can appeal to ancient Hindu tradition, ancient Egyptian tradition, or ancient Babylonian tradition, and we'll find those same themes repeated.
Many of them feared the sun, and a great many of them feared that when the sun moved toward the south, getting closer and closer to the winter solstice, that the sun would not stop. The sun would continue going southward, it would disappear, and the world would perish.
In time, you see people investing symbolic meaning with the sky, and they take that symbolic meaning, which is a reflection of the things that are important to them in their own lives, and they incorporate it into their sacred places.
At Stonehenge, one can stand at the center of that huge monument using very massive stones that have been transported for very long distances. At Stonehenge, we have one outstanding astronomical alignment. It's called the heel stone that you see from the center of Stonehenge, and at the summer solstice time, the sun is rising directly over the heel stone. Well, that probably is not accidental. That is an observation that was made into Stonehenge.
Stonehenge, in a sense, while maybe unique, is hardly alone. There are 900 stone rings in Britain alone, and those are just the ones that are left. And there are other kinds of monuments besides these stone circles that also are very good candidates for astronomical alignment.
There's the Bighorn Medicine Wheel in northern Wyoming, for example. That also has a summer solstice sunrise alignment, a very definite one. In that case, that's a monument made from small stones, many of them being piled up in what looks like a wagon wheel kind of pattern. It apparently has some of these heliacal risings of stars that predate and follow the summer solstice that are built into it as well.
Now, of course, the question is, who built it and what did they use it for? You begin to wonder, are we dealing again with an attempt to make astronomical observations? Are all these structures the same? What exactly is going on? And of course, the real answer is, we just don't know. Each one is a product of the culture that built it. In part, it has to do with a concept of religion that is related to what people might call a showing of the sacred. The sun or the stars or the moon or whatever they might be, representing as they do powerful cosmic forces that move and order the world, make their presence known and in key places, and in turn make those places sacred. And so whoever's there, the pharaoh, the king, the priest, whatever it might be, that person becomes a participant at this right place, at this right time, for this showing of the sacred that kind of puts the cosmic good housekeeping seal of approval on that society's activity.
Ancient cultures grounded their astronomy in myth and legend and built great monuments to support their beliefs, until the arrival of a civilization that brought a new perspective to the images of the sky.
Certainly something very interesting happened in the Mediterranean at the time of the Greeks. Greek science is something that we can clearly see the roots of modern science in. And it has to do with this sense of modeling the universe mathematically, being able to predict what might happen next, and being able to test and reject ideas on the basis of rational thinking. That kind of approach, kind of a skeptical approach to nature, isn't the sort of thing that we would necessarily find in any of the sacred kingdoms that depended on a mythological worldview.
With their new worldview, Greek astronomers analyzed and categorized the sky based not on myth, but on objective observation.
One of the things that we notice when we go out at night, whether we're astronomers or not, is that stars have different brightnesses. They're faint stars, they're bright stars. The first person to use the term magnitude in an astronomical sense was Hipparchus. He divided the bright stars up into 6 groups. Group 1 was the brightest stars, Group 6 was the faintest stars. These magnitudes that Hipparchus set up were obviously visual magnitudes. They're magnitudes as we see them with the eye, and the average eye is always the same. Now, of course, when we got telescopes, we could see stars fainter. And so we have to apply magnitudes to those stars. And so the magnitude scale goes from 6 down to 10, down to 15, down to 20, and so forth. The larger the number, unfortunately, the fainter the star is.
The Hipparchus magnitude scale is somewhat inconvenient for use today, and that is due to the fact that the scale is pretty much upside down. The bigger the number, the fainter the star. It becomes a little more inconvenient when we have to look at objects that are brighter than the stars. For example, take a look at the planet Venus. In the Hipparchus magnitude scale, Venus would have a magnitude of -3 or -4. In other words, for objects brighter than the brightest stars that Hipparchus could see, we have to use negative numbers. And the moon would even end up being a -11 on this scale.
The Greeks struggled to explain this awesome spectacle of lights with their newly conceived scientific methods.
But the ancient Greeks did something that, so far as we know, no one had ever done before. They tried to build models. They tried to build actual physical descriptions of what the universe was like. Nobody had done that before. Living on the Earth, it's really hard to understand what the universe is like. When we look at the sky, it looks like a great plaster dome overhead with the stars stuck on like thumbtacks. And in fact, that's the way the Greeks thought the universe really was. And they created the idea of a celestial sphere, a globe that completely surrounded the Earth. And the stars were stuck on the globe like thumbtacks in the ceiling. We know that's wrong now. We know that the stars lie at all different distances from the Earth. Some are very far away, and some of them are really quite close. But still, the celestial globe is a useful model.
Using the concept of a celestial sphere, the Greeks described what appeared to be a sky in motion.
It doesn't take very long before one notices that the night sky changes over a period of time. We notice that these constellations, as a group, move across the sky from east to west. We get the impression that the sky is literally turning above us. On Earth, we don't feel the Earth moving at all. Therefore, the logical conclusion was, and this was made by the ancients, and just about all ancient civilizations made this conclusion, was that the celestial sphere, the giant sphere of the heavens with the stars imprinted upon it, was moving, was rotating slowly, recreating that daily motion, the rising of the stars in the east and the setting of the stars in the west.
Using the celestial sphere, the Greeks defined the 2 most important lines on the sky, the celestial equator and the ecliptic.
The celestial sphere has a globe of the Earth in the center, and the rotation of the Earth on its axis defines the north and south pole on the sky, and it defines the celestial equator. The celestial equator is the line around the heavens exactly above the Earth's equator. That line divides the heavens into a northern hemisphere and a southern hemisphere. We can see that that line is defined by the rotation of the Earth. The Earth has another motion. The Earth revolves around the sun in an orbit, and that defines a line on the sky.
This path that the sun seems to follow over the course of the year as a result of the Earth's motion around the sun is called the ecliptic. If we could see constellations behind the sun, then we would notice that the position of the sun relative to those background constellations is changing as the Earth orbits. Its name probably originated from the fact that this was the zone in the sky in which eclipses occurred, hence the name ecliptic.
While the Greeks gave us a new perspective on the sky, the motions they described were more than mere celestial phenomena. They were cycles that, in fact, ruled life on Earth. On this planet, we live within two major cycles, both determined by the apparent motion of the sun.
The sun, after all, does some things pretty much the same for everybody. It orders the world. It comes up every day and goes down every day and brings light to the world. And then over the course of the year, it follows a pattern that establishes direction in the landscape and also consolidates the calendar into a repetitive cycle. It changes the height of its crossing through the course of the year. This was linked in turn to the weather, and the seasonal change obviously modulated the behavior, not just of the rest of the animals and the plants, but of people themselves. Well, that is power, and people were right to recognize that power. They attributed to it a divine source, whereas we today, of course, recognize it as physical.
The Earth rotates on its axis in 24 hours, and that makes the sun rise and the sun set, and that produces our cycle of day and night. Our bodies are tuned to that cycle, and we awake and we sleep with that cycle.
Proof of the Earth's daily motion can be seen in a Foucault pendulum. As the pendulum swings, the plane of its motion defines a fixed direction in space. Since we know inertia prevents a change in that direction, the pendulum's observed motion around the room must be caused by the daily cycle of the Earth's rotation.
The other cycle is the orbital motion of the Earth around the sun. The Earth travels around the sun in 1 year. The Earth goes through seasons, and we live within that cycle too. We're creatures of those two cycles determined by the two motions of the Earth.
Traditional people noticed this. They didn't explain it as we do, of course, today. They thought of the sun as moving around us every day. They thought of the sun as usually as a deity of some sort. Certainly they knew that it was essential to their very existence. And this change that occurred throughout the year, every single year, was very, very important, very fundamental.
If we were to keep track of the motion of the sun in the sky over the course of an entire year, we would discover that the sun does not rise at the exact same point in the east every day. In the month of June, the sun rises far to the north of the east, and from a northern hemisphere view, the sun reaches its highest point in the sky along its ecliptic path. And we define that point as the summer solstice. It would correlate to the longest day of the year in the northern hemisphere.
The solstices and equinoxes around the ecliptic are marked on our calendars today as the beginning of the seasons. Many cultures celebrated those with holidays. The summer solstice was often celebrated as the beginning of the summer season, the beginning of the intense growing season.
Towards the end of September, September 20th, 21st, we would reach a point where the sun would rise due east. It is at this point that the sun, along its path, crosses the celestial equator. The length of day and the length of night would be equal in time, and we have the equinox. The autumnal equinox in September was often celebrated as the harvest season.
was a time when the harvest was gathered and the fruits of the summer's work were brought in.
Finally, in December, around December 20th, 21st, we would notice that the sun would rise far to the south of east. As it moved across the sky, we would discover that it would be very low in the sky for Northern Hemisphere observers. The days would be short, and as a result, we would have a day called the winter solstice.
The winter solstice was often celebrated too. It fell at a time when people couldn't farm, and they would celebrate that solstice as the midpoint of the winter season. So many cultures had ceremonies, prayers, celebrations to appease the sun and to call the sun back into the northern sky so that spring would come and the earth would come back to life.
As the year progresses, the sun continues its journey along the ecliptic path, finally reaching a point in March, around March 20th, 21st, again, a point where the sun would rise due east, crossing the celestial equator. We would have, again, equal length of night and day. We would have the spring equinox. And the cycle continues.
To the people of ancient and traditional cultures, the seasons were caused by the annual migration of the sun. Today, we know the real cause is much closer to home.
We have seasons on the Earth because the Earth's axis of rotation is tilted away from the perpendicular to its orbit. The Earth is tipped slightly toward the sun, and you can see that the sun is north of the Earth's equator. And from the United States, the sun will cross high in the sky, we'll have warm weather, and it'll be summer. Now in 6 months, the Earth will revolve around to the other side of the sun, but notice the axis of the Earth is still pointed in the same direction. The sun is south of the Earth's equator. And that means that through the day, the sun doesn't come very high in our sky in the United States. We don't get very much heat from the sun, and so winter days are cold.
Just as the motion of the Earth changes our perspective of the sun, it also changes our view of the nighttime sky.
If we set up an observing schedule and go out and look at the night sky, say at 9 o'clock every night for days and weeks and months, we discover that the groups of constellations change. In other words, during the winter months, we would be able to observe the constellations of Orion and Taurus and Gemini. And yet, if we were to do the same observations at the same time, 6 months later, we would observe the constellations of Hercules and Sagittarius and Scorpio. This led the ancients to believe that there was a yearly cycle to the motion of the sky, in addition to the daily motion of the rising of the stars in the east and the setting of the stars in the west.
By carefully watching this yearly cycle of stars, the ancient Egyptians discovered another earthly motion, one so subtle it was detected only over hundreds of years.
They built temples that were aimed at the rising point of important stars like Sirius, and they noticed that after a century or two, Sirius wasn't rising in the same place anymore. So they had to modify their temple and twist the hallways to make them point toward the right spot. They saw precession.
Precession is the phenomenon that occurs when a spinning top wobbles on its axis of rotation. The Earth does the same thing. It's wobbling. Due to the gravitational effects of the sun and the moon, this axis of rotation is slowly tracing out a circle in the sky. It's moving, not tipping over, but wobbling very slowly. In fact, it takes approximately 26,000 years for the Earth to make one complete wobble on its axis.
That precession has even changed the North Star. Thousands of years ago, when the ancient Egyptians were looking at the sky, they didn't see the same North Star that we see. The North Celestial Pole pointed toward a different star. And in a few thousand years from now, our descendants will no longer have a star near the North Celestial Pole. We can actually detect precession with telescopes rather quickly. In a matter of months, you can tell with an accurate telescope that the stars are not quite in exactly the same position that they were just a short time ago. So precession is a continuing process, but it takes a long time to go through one complete cycle.
From an Earth in motion, the sky presents a magnificent ballet of lights, an elegant dance that has gone on for thousands of years. Today, through science, we understand the sky more clearly, and still it fills us with a sense of mystery.
There's a favorite poem of mine that comes from the Algonquin Indians. These are Indians that lived in the eastern part of the U.S., woodland Indians, that expresses the sky in a very beautiful way. We are the stars which sing. We sing with our light. We are the birds of fire. We fly over the sky. Our light is a voice. This is the song of the stars. People throughout time and in different places have, so to speak, listened the song of the stars in ways that made sense to them in their time. Astronomers today do the same thing. You could say that they too are listening, maybe more accurately and more detailed, to the song of the stars, trying to understand the words and the phrases, trying to get more out of the energy, out of the voice of the star, if you will, that comes so far across space to reach us.